All right,
Awesome.
everyone. I hope everyone had a great weekend. Good morning, good afternoon, good evening. What is up? I am your host, Charlie Shrem, and you're listening to another epic episode of the Charlie Shrem Show powered by Waxman, where together, twice a week, we get to dive deep with some of Bitcoin and crypto's most influential leaders, those who are building out some of the coolest projects, the software, the technologies that are going to be powering everything that we're doing today and tomorrow. And we tell some fun stories at the same time to understand how this movement came to be, connect a lot of the dots, figure out what the hell is going on under the hood. And there's a lot of really good things happening. There was, even though the macro environment is happening around the world the way it is, it seems like finally we went through this like Bitcoin and crypto winter. Maybe we're coming out of it, but a lot of really cool pieces of software and projects have been coming online over the last year or so. And we've been focusing lately on crypto projects that are enabling for connections between and bridges between itself and Bitcoin without losing decentralization. And kind of that's been like our theme over the last few months. I love diving into about a year and a half ago, we actually had someone from the DFINITY Foundation. We talked to one of the founders about the internet computer you guys have all heard about. And today I'm excited to have someone back, the director of engineering, Manu Drijvers. Thank you so much. I screwed up the way I pronounce your last name. I'm sorry, but thank you so much for coming on the show today.
That was actually pretty good. And yeah, thanks for having me. It's a pleasure to be here.
So in a second, you're based out of Zurich. The DFINITY Foundation's, it's one of the oldest, I think, projects in the space building out the internet computer. For those who don't understand, before we get to the Bitcoin side of things, how would you differentiate, the internet computer from other EVM-based smart contract platforms? Most of them we already kind of look at, like Ethereum and Polygon.
Yeah, it's a great question. I think the vision of the internet computer is really to, we think that smart contracts are a super powerful tool, a super powerful way to run software. But if you look at the software of the world today, only a very small fraction kind of fits as a smart contract, right? Because there's a lot of limitations still. And I think the vision of the internet computer is try and take away as many of those limitations as possible, so that more and more software can run in the extra secure setting of a smart contract. So things like scalability and being efficient, like cost efficient and efficient computation, are all big design goals of the internet computer. So maybe to answer your question, I think, so I guess first of all, the internet computer is not EVM, but we run WebAssembly smart contracts. So that's one difference.
We have to like zoom out for a second, I think, a little bit here, and because how would you, if someone said to you, categorize for me all whatever people call blockchains or protocols, how do you break them down? Because it used to be just UTXO based and then account based, and then now it's moving. It's like there's so many different categorizations. They're almost like it's like finding a new species.
That's true. Yeah, it's maybe hard to have clean separations. So the internet computer is a layer one blockchain, and I guess we use accounts, but really the goal is to have smart contracts be as efficient as they can and run as much as possible. So from the beginning, we support, I guess, sharding, or we call them subnets, such that we can have many different blockchains, which allows the internet computer as a whole to scale and run more and more blockchains, and thereby grow its capacity. And to get efficiency and like cost efficiency, we also try to make it so that I think many blockchains try to maximize replication, so have as many validators as possible, and replicate more and more, which gives security, but is also very expensive. So I think one differentiator that the internet computer takes is try and maximize decentralization without replicating it too much, such that it becomes too expensive.
That's the biggest problem, as all scaling so far is, to me, just pushing the can down the road. If right now all of our different companies with the crypto ecosystem just overtook the world's financial networks, messaging networks, content delivery networks, if we just took over everything today, we wouldn't have the capacity to do so. We're not there yet. And so like that's a really, really interesting differentiator right there, that you're not focusing on scaling the normal way. It's like the bigger you grow, the more validators, the more nodes you want to have, is the more decentralization you have. So how do you get more decentralization and scaling without losing, like without going towards centralization?
Yeah, well, of course, that's challenging. So the view we have is, I think some people call this like this deterministic decentralization. So the node providers are known entities. They have to identify themselves if you want to be a full node participating in the system. And the view is that like each subnet should be as distinct as possible. All the nodes that power one subnet, so one blockchain, they should be as distinct as possible. Meaning like ideally different countries, different cities, different data centers, different operators, all those things. Because often what you see is that you have many nodes that are all like validators or full nodes, but in reality they might all run on AWS or in the same place, which I think adds limited.
Good point. Like, what's the point, right? It's not about the number of nodes. It's like there should be almost like a scoring mechanism from a node. It's like, how decentralized is that node? And then
exactly
that creates like a weight, and then you can focus on decentralization that way, because a node running on its own hardware, when its own internet service provider, owned by, with its own, connections and cables, like there's a lot of physical limitations to running a node, because you can run a node all you want at your house, but at the end of the day, your ISP controls the internet that comes out of your house. So that node is not really decentralized. Or if you're keeping a node on Amazon Web Services, the same thing.
Exactly. So we try to factor that in, and
how?
So one part of that is that like, as if you want to participate in the system, you need to like identify yourself. But now the big question is like, who decides how these things are formed, right?
Always.
And so this is done by basically the whole internet computer is governed by a big DAO that we call the network nervous system, or the NNS. So ICP token holders can choose to lock up their tokens, and then they get voting power. And this DAO orchestrates everything essentially. So anybody can submit proposals, for example, to create a new subnet with a list of nodes, and now the voters can vote and see if they think that makes sense or not. And so here the voters will look at these nodes and see, does this make sense from a decentralization perspective or not? And maybe they say, oh, we already have so many nodes in the United States, maybe we want some more nodes in other countries, or things like that.
That's interesting, because typically it's like you have to stake your tokens, and then you become a validator or a node, and then you vote with your weight. Where here it's like you're separating the node operation and then the actual staking and voting mechanism. But to further, most people aren't going to be validators or nodes, and so you're not rewarding the like quantity, you're rewarding the quality.
That's right. Yeah, that's right.
Very interesting.
Yeah, so
take on
there's
it.
even now proposals coming up that change the reward structure depending on how needed certain nodes are, right? So for example, now we have more nodes in the United States than in other countries. So now there's a proposal that will change the rewards for nodes in other countries to maximize decentralization that way.
That's really cool. You think that the future is through validators and nodes?
It's always hard to say for sure, but I mean, I do think that
It's like individuals.
if you dream big, right, and you think Web3 is going to take over the world and it needs to run, a significant chunk of the world's software, then we need to be much more efficient than 1,000x replication, right? If everybody executes the same code, that's not going to be efficient. So you need to find something to avoid that. I think that's the clear must. Otherwise, it just is prohibitively expensive. And I think this approach with subnets and trying to maximize decentralization without too much replication is one path towards that.
It almost like focuses on that where the computation needs to happen. It focuses on using resources just for that computation. And I guess what I'm getting at is it's like in other blockchains, every transaction has to hit every validator and every node on the network, no matter what you're doing in real time. Where here it's like almost how the brain operates. And you mentioned like subnets and things like that, but it's like, remember that image of the brain, and you had different areas of the brain pulsating at different times, and your body knows where to send those electromagnetic pulses at a given time in order to function the rest of the body. And that almost feels like a more natural way of how you guys are doing it.
Maybe, yeah, that's a nice analogy.
Yeah, I'll send you my invoice.
That sounds good.
Okay, so like over the last, well, actually before that, tell me a little bit more about your background, because it seems like your passion is this like prevention against what, like attacks on the internet, or I know you studied cryptography, you published a lot of papers on it, a lot of research, and I encourage, we'll actually have links to a bunch of them that we can have in the show notes here. But you worked as an IBM researcher, but like, what drives you?
I mean, I think cryptography is just super, super interesting. It's like very nice math that has like a very clear real life purpose of keeping the world safe and the online world safe. So yeah, I did research in this, which is very interesting. And during my research, I also, of course, looked at Bitcoin and other projects, and I followed this with interest. And then,
yeah,
I think in the beginning, the cryptography there was quite limited, right? It was mostly just like signatures and proof of work, but not too fancy constructions. And then this also changed over time, and a lot of blockchain projects employ more and more advanced cryptography. I was looking into multi-signatures and Bitcoin. There was some Bitcoin proposal to use certain multi-signatures, and then we looked at the security of that and found some problems, and then things became better. So this was all super interesting. So after some time doing research in cryptography, I heard about DFINITY and a chance to actively work in this field and try to bring a lot of these advanced cryptographic protocols that we were mostly writing papers about and make them a reality, and that you can actually use them. So that was very exciting, and is a very interesting job in my opinion.
That's actually people don't. When I talk to people about this, they don't understand how beautiful it is, but the consistency of math in everything, in nature, in what we do, energy, it not just keeps the world safe, like you said, but it's everything. And so I find like a powerful inner peace personally whenever I'm working on something that revolves around math or physics, because it creates like not just a constant, but it creates like a nice finality sometimes, at least in the current state of the world, because we don't understand time fully. And if we look at time as this like constant moving thing, then we don't know all of the variables sometimes. So I'm excited for humanity to like unlock more things. But there is so much beauty in that. And when I fell in love with Bitcoin and the idea of decentralization and cryptography, it all coming together, and like how it really powered the first waves of the early internet, and how it's bringing us into like the next world, that is what also got me in it. That's like that I completely get it.
Yeah, and it's exactly like you say, like this cryptography is very often very like precise, right? You can very precisely formulate, okay, I want this security. This is the precise mathematical definition I'm looking for. And you can make very precise statements about, okay, this construction that I made up satisfies the definition of security under exactly these computational assumptions. And that's it, right? I guess, unless you made a mistake, but so you can make very precise statements and very thoroughly analyze things with real world impact. Yeah, that's very exciting to me.
Do you think that you would, because do you think that, you know, you got into Bitcoin, you got into crypto, everyone goes and at some point in time, like reads the original Satoshi white paper, they study it. Do you think working in crypto, you can still call yourself a Bitcoiner? And what is that? What does it mean to you to be a Bitcoiner?
Yeah, I mean, I wouldn't call myself a Bitcoiner, but I am, of course, broadly a blockchain supporter and very interested in the whole field. I think some of these words are have a bit of a negative connotation because
Oh, really?
I guess you have a lot of whatever overly enthusiastic.
No, remember that. Remember that old. I don't know if you remember, like John F. Kennedy made a speech about the Berlin Wall, and he said, "Ich bin ein Berliner." You know, we're all, and so I kind of say like Ich bin ein Bitcoiner. We're all Bitcoiners at heart because all of crypto that we know today grew out of that, the beauty of the invention of Satoshi. And so it's okay. Bitcoin maximalists became Bitcoin maximalists because they choose to be ignorant on the education of crypto. So if you talk to most of these maximalists nowadays, they can't even explain to you what you do because they choose not to learn it. That's their fault. That's their fault. But there's been a huge embracing of like the collaborative cultures of what it all means to be one and the same.
Yeah, and I think there's a lot of healthy. I mean, of course, I'm a supporter, right? But I think it's very good to also have healthy criticism and look at everything you do with a critical view. But yeah, no, I absolutely agree with what you're saying.
You guys also have been building out your version of a bridge for Bitcoin and the internet computer to work together. So it's not just about, it's called ckBTC. It's not just about like wrapping Bitcoin. How does it work? Like, because I deeply study this. I'm trying to understand all the different bridges, the different protocols that are building out, their decentralization limitations, their centralized limitations, where they fall short. Like I've been studying them like crazy. So tell me how this works.
Absolutely. Yeah. So we set out with the goal that smart contracts on the internet computer can actually programmatically hold and control native Bitcoin. So this is Bitcoin that lives on the Bitcoin blockchain. Oh. And you kind of need two things for this. So if you want to hold Bitcoin, you need to be able to look at the Bitcoin blockchain and see which unspent transaction outputs you have. And you need to have a key that you can sign things with so you can send some of those UTXOs away to others. And so what we built is interfaces for smart contracts to get exactly those two things. So the first is, you need to know your UTXOs. So we built one smart contract, one special smart contract on the internet computer that maintains this state. So it maintains the state of all the Bitcoin UTXOs that are valid at this time, which is powered by the nodes that power the subnet. And so there, your smart contract can just ask this other smart contract, hey, what are the UTXOs of this address, or what's the balance of this address? Things like that. So
it's the your node operators are basically maintaining their own copies of the Bitcoin ledger.
Exactly. So they participate in the Bitcoin network to obtain all the latest blocks.
Okay.
And so this solves the first part, right? Now my smart contract can figure out who has which UTXOs. But now having a signing key is the big challenge. Because for my smart contract, it's very difficult to have a signing key that remains secret, obviously. So what we built is a threshold ECDSA protocol, which is essentially allows a smart contract to request a signature on a certain message. And then the nodes that power the subnet collaboratively construct a signature on behalf of this smart contract. And so this uses threshold cryptography behind the scenes. So it's a multi-party protocol that constructs such a signature without any secret key ever existing in one place. And so with this
signature on your blockchain or on the Bitcoin blockchain?
So my internet computer smart contract can request a signature, which the nodes of the internet computer subnet will generate for my internet computer smart contract. And that's a signature that is an ECDSA signature, so it's valid. I can use that to sign transactions that will appear on the Bitcoin blockchain.
So you can build, so your validators manually build a transaction using signatures that were created on your between your validators. Totally get that. They build a transaction, they broadcast it to the Bitcoin blockchain. And so do you have to wait for a full Bitcoin block to do anything then on your wrapped Bitcoin per se?
Yeah, so it's important we distinguish two things. So what I just described is kind of how an internet computer smart contract can work with native Bitcoin. So if you believe that these two things work, then I can now write a smart contract on the internet computer that programmatically deals with Bitcoin and submits transactions that will appear on the Bitcoin blockchain. But now you raise the point of speed, right? So of course, if you deal with native Bitcoin, then you need to wait for the native Bitcoin confirmations, which is for some applications fine, and for some applications it's not fast enough. So on top of this native Bitcoin integration, we built a smart contract, which we call this ckBTC chain, referring to our chain cryptography, as we call all these threshold algorithms. And this ckBTC is similar to a wrap token, where you can send native Bitcoin and receive a different token, which you can transact in quickly. So that's an internet computer native token. So and now the unique. Sorry.
What? So before you get on the what's the unique thing?
So the cool thing about this is that often it's some centralized group of entities. If you think about some wrapped token, it's often some centralized entity or group of entities that hold the underlying token, and they issue you a new token on a different blockchain. And we've seen problems with this, right? If the issuer of such a wrapped token disappears, then your wrapped token loses all its value and the underlying funds might be gone. And so the interesting thing here is that because internet computer smart contracts can hold native Bitcoin, this conversion between this native Bitcoin and ckBTC can happen fully by a smart contract. So the assets are held by a smart contract. Everybody can see them. They're not going anywhere because the smart contract controls them. So this risk of a third party running away with the underlying funds or disappearing with underlying funds is mitigated with that.
How is the signature being created? How many validators are they all holding a piece of like a broken up private key? Correct.
Yeah. So this uses techniques like Shamir secret sharing, if you heard of that. So pieces of a key are indeed shared, and they can collaboratively sign without just revealing their secrets.
When you create a subnet, you define all these parameters, right?
Correct.
Okay. So I understand that. So there's a mechanism in which you can lock your Bitcoin, and on the Bitcoin blockchain itself, all it looks like is a transaction from one place to the next. But then that goes to like some sort of treasury or your like individual subnet treasury. So it's not like a main treasury. And if there's a hacking situation, it's only to that specific subnet, which is good. So you're like have a modular ecosystem here. And then at the same time, the unlocking mechanism would also take a Bitcoin block, but as long as you're willing to like be okay, like you said, a cup of coffee, you don't need to wait a full block. Do all transactions eventually get settled on the Bitcoin blockchain? Does it like or do you have to like wait until you withdraw? Like, are you checkpointing the Bitcoin blockchain, or is it only at a withdrawal mechanism are the unspent outputs now can be reused on the Bitcoin blockchain? What's that relationship like?
So for this ckBTC, which is like a wrapped token, it's not everything is written to the Bitcoin blockchain, such that that can go very fast and it doesn't all need to be written there. And also those transactions can be much lower cost than if they would all need to settle on the Bitcoin blockchain. So only when you move Bitcoin in or out does it actually show on the Bitcoin blockchain.
I want to like completely change the subject here for a few minutes. AI has been like the big buzz lately, and ChatGPT and some of the other ones. What's going to be the relationship, do you think, between crypto and some of this AI?
That's a very interesting question.
I know. I just figured like you're a great person to ask that. I'm sorry for throwing it out. I don't know the answer.
It's a great question. It's very interesting. So I mean, you already see a lot of applications in writing code, right? Maybe verifying code, finding bugs, I think is very promising. So I think on the building side, I think it definitely will be a big tool. I'm curious if we'll also see like more on-chain AI. I guess that's maybe a bigger challenge and maybe a bit farther away. But
AI with an incentive layer. That's kind of what I'm looking at.
Yeah, or a transparency layer, maybe also, right? I think like a lot of these bias problems and I think one big challenge of all the AI algorithms is that they're not very transparent, right? Nobody really knows why it suggests something.
Does not like me. I had a whole it's putting me in a little bit of a bad mood the past few days. I've been debating ChatGPT about myself, but ChatGPT thinks Charlie Shrem is like not a good person. I'm serious. You can go.
Oh, man, that's rough.
It's like I'm very controversial. I already knew that, but it's like ChatGPT says that people's perception of me, because I had success and then I lost it all and I've just been trying to get success again, because then I could seem like self-serving. And I'm like, oh no, is that what the world thinks of me? And then it said that, and then I'm like, well, why is Charlie Shrem being judged differently than the rest of the world? Like, why does Charlie Shrem have to like get judged this way? And it was just like this, and it talked about bias, and then it was like Charlie can just do all these things, and it was like basically just retire. Like Charlie just stopped doing everything, and I was like, well, it's great.
Wow, yeah. So if this was on chain, then you could maybe figure out.
My wife is not letting me use it anymore now. Is people are probably listening, going to go do that now, and they're going to see it's like there's a huge bias. You can, if you're someone with even a little bit of like a public perception, a lot of these AIs like, and we don't know what the bias is. It's so bad. It's like almost worse than fake than like, it's almost worse than like a subversive government paying Facebook to run ads about, a country's political campaign or something like that. It's like worse, because at least there, what's happening. Where in AI, you don't know where the bias is. It's a really freaking scary thing.
Yeah, that's true. And it's quite influential and powerful. So
it needs a transparency layer. It needs a transparency layer. It needs to be open source. It needs an incentive layer. It's like with decentralization. I understand that like there's a path to decentralization. You're not going to get there. Today, it takes a while. But if you're transparent about it and you eventually get there, that's what's most important. I love having guys like you back on the show talking about what the internet computer is doing in different projects, because you guys are on this like beautiful roadmap and coming out with new things and new projects and new services. But it's like something like that just really scares me. And no one realizes that ChatGPT is owned by the same guy who's trying to do that world coin where they scan your iris and create like a data set for every single person.
Oh, yeah, I actually did not know about that.
It's a scary, yeah, it's a scary thing. World is considerably a scary place, but that's why we have this show and we get to work in crypto because it feels like it's the only positive industry in the world lately.
You know, we have our work cut out for us.
Yeah, though it's fun though. We're doing, like you said, we're using math to save the world. It's not just about passwords. It's about what we just talked about. It's about transparency. It's about creating equal opportunities for every single person.
Yeah, absolutely. That's a good. Next time my grandma asks what I do, I should I should use that.
Yeah, right. Do you going back to the Bitcoin to wrap Bitcoin for a second? Do you think you're building this out for Bitcoiners to interact with the internet computer and then all the other blockchains and subnets within it? Or are you more looking like, hey, folks who are in crypto want to be able to own some Bitcoin and then interact with that? Or is it both? Could be both.
I think it's both. I mean, of course, we think it's beneficial to the internet computer ecosystem to have more, to be able to tap into this Bitcoin liquidity, right? There's huge value there. It's the oldest and most well-known cryptocurrency. At the same time, I think you also see maybe more, like you see a rise in Bitcoiners that want to do more with their Bitcoin, right? And, I guess recently the ordinals got a lot of attention.
Yeah.
But now if you want to have a good marketplace for ordinals, how do you do that? So I think this functionality, I hope that some of this functionality will also appeal to Bitcoiners that say I would like to do more with my Bitcoin and use it in smart contracts and take this path.
I agree. I think that's you're seeing this, like, it almost goes we were talking about this the other day. It's like going back to when all blockchains kind of work together, from a culture side of things. Like you said, like certain words are like almost like toxic. You can't use them anymore. But in a world when we're not competing anymore in terms of, for like, I don't know what it created, this like negative, we need to compete for the world for like the one and only blockchain. And a lot of these bridges and mechanisms for Bitcoin, all blockchains to work together, when that happens, you'll see the toxicity kind of wear off.
Yeah, absolutely. I mean, it would be nice if I mean, I do think the space moved in that direction, right? So there's more maybe multi-chain acceptance now and the collaboration over competition. And I think it's at the end of the day, of course, good for the whole space, right? We should maybe, I guess, with my more academic background, there you also try to just advance the state of the art, right? Not necessarily disprove somebody else or so.
Yeah, like a positive instead of just like disproving a negative. Well, it's not just like our whole industry, it's like the rest of the world that is kind of dealing with it now. But it's a beautiful place, and we're in this so far, the first few months of the year have been really positive for our whole industry and for a lot of people. Are there any conferences that you're going up to coming up?
I don't know if trips planned now, but I hope to join some soon again.
I want to go to ETHCC in Paris and then Bitcoin 2023 in May. Those are kind of my plans right now.
Nice.
Good trips. I'm really excited. Well, Manu, thanks so much for taking the time and coming on the show today. Really appreciate you talking to us and giving us some insight into how you guys are solving that decentralization issue and bridging everything together, and how the internet computer works and how it differentiates itself from and apart from everything else.
Yeah, my pleasure. Thanks for having me.
I'll see you later.
Bye.